Yeah. Yeah. So I slept for a while, and I'm going to restart the live. So, oh wait, let me share. Oh my god! Start this, like this, and then go to. Okay, we're going to look at big O of n square. There we go.
There's a lot resting on Bellingham's shoulders. If you look at Jude Bellingham, this kid's one of the best players in the world. He's a massive.
So in this video, we are going to talk about what is ON square or quadratic time. So if you see the definition, that is, we are going to talk about ON square. It means the runtime is the square of the input size. It means the more and more input that you are giving, it will automatically will be n square times. For example, input size is n, then in that case, the time complexity will be n square times. That equation is also called mathematically quadratic equation. Some example like bubble sort is one of the best example for the ON square time complexity. So let's see how exactly we can calculate the time complexity. For example, we have nested loops and one outer loop and one inner loop, maybe two for loops that we have in the nested form. When we have one while loop and internally we have one for loop, then in that case also we will get the ON square time complexity. So I'm writing a simple basic code. For example, let's see, I'm writing a for loop here, and then I'm writing with I is equal to 0. And then I'm writing, let's see, I is less than equal to 5. And then in that case, the time complexity will be n square times. That equation is also called mathematically quadratic equation. Some example like bubble sort is one of the best example for the ON square time complexity. So let's see how exactly we can calculate the time complexity. For example, we have nested loops and one outer loop and one inner loop, maybe two.
ಇವ್ರು ನನ್ನ ಮುಚ್ಕೋಬೇಡಿ.
ಇದ್ದಿತ್ತಂತ
Two for loops that we have in the nested form. When we have one while loop and internally we have one for loop.
ಇವ್ರು ಮೀರದೆ
ನೆಲ್ಲಿ ಸಂಪೇಶ ఏమి టామ్లో ఆ కామె వస్తుంది తాను అట్లా వస్తుందిరా చూసేది అగ్గి మరి ఏమి నిజం అనుకునే అలా జనాలు
క్రీమ్ లేకుండా తీసుకోమ్మా.
బిస్కెట్ ఇది ఎక్కడ ఎలా ఏం బాగా వచ్చేసిందో జనవరి సలహా ఉండదా
Dor com barra meeting.
నోరు మూసుకో ఐ హావ్ మీటింగ్
Dor com barra meeting.
లోటస్ మమ్మీ మమ్మీ అయిపోయినారా
Hey, meeting started. Hey,
ఎవరితో
very good.
దయ సిస్టర్ బయటకు పోయి డోర్ ఏమన్నా బయటకు పోన్నా బాగుంది సెటప్ బాగుంది
Then in that case also we will get the ON square time complexity. So I'm writing a simple basic code. For example, let's see, I'm writing a for loop here, and then I'm writing with I is equal to 0. And then I'm writing, let's see, I is less than equal to 5, and then I plus plus, something like this. And then I'm creating two more variables. For example, integer m is, let's see, is equal to 5. And then I'm writing integer n is equal to 5 also. So I'm saying instead of 5, this algorithm, this for loop is actually based on m here. Okay. Then what I'm going to do, I'm writing another for loop inside this particular outer loop. Let's see, j is equal to 0, and then j less than equal to n over here, and then j plus plus. And then I'm doing something. For example, let's say I'm just appending I and j together. So for example, I'm just simple writing I plus j with the, like this, with one space also I'm appending. And once the inner loop is done, I'm just putting a new line, creating a new line. So what will be the output of this program? First, let's see when you run this, and here you can see that the output is coming in this particular format. And if I remove the ln also from here, because I don't want to generate the new line after the first statement, then it's the output is coming like this. You can ignore this one. This is some other code that I have written here that I'll show you in the sometime. But here you can see that it's printing from 00 to 55. If I include, let's say, up to 9, and m is also 9 and n is also 9, then in that case it is running this kind of pattern. 00 to 99 pattern is coming. So if you observe one thing, let's say again back to 5 and again back to 5, if you observe one thing here, that, let me just remove this particular code for time being. I equal to 0, I is less than equal to m. This is the outer loop and this is the inner loop. So for I is equal to 0, this entire inner loop, j equal to 0 up to 5, it will be executing. And then again, I will be increased by 1. Then again, for I is equal to 1, for loop will be running from j equal to 0 to up to n. So likewise, for every value of I up to 5, the value of 4, the value of j inside the inner loop will be keep running in that case. So how to calculate the time complexity in this case? So in order to calculate that, let's see, you have to derive the formula at the time of interview. For example, let's see, you can just ignore this because this will give you 1 plus 1 only. So let's start from here actually. I equal to 0 for the outer loop. So I'll do one thing for the outer loop. I'll put in a bracket here like this. I equal to 0, how many times it will be executing? It will be executing only once. And then I'm saying that I less than equal to m. It means this condition is based on m. If m is equal to 5, it will be executing 5 times. If m is equal to 10, it will be executing 10 times. So I'll say, okay, it will be executing n number of times. The moment the condition is satisfied, immediately it will come to the inner loop. So for inner loop, I'm going to do a product over here. The multiplication, I'm going to write in a separate bracket here like this. I'm not going to add because these three statements will be added, but the inner loop will be multiply with the outer loop here. Okay, so in that case, let's see j equal to 0. How many times it will be executing? It will be executing once again 1 plus j less than equal to n. This guy also is actually totally dependent on n. N means the number that you have written. So let's say I'm saying that, okay, it is getting executed n number of times. Then the moment condition is satisfied, it will print this particular statement. Then I'll say, okay, fine. This statement also will be executing n number of times. This number could be anything, 5, 50, whatever it is. And then after that, the value of j will be increased. So I'll say, okay, fine. The value of j also will be increased n number of time here. Okay. Then once this is done, then after that it will generate a new line. Okay, fine. The moment condition is satisfied, it will print this particular statement. Then I'll say, okay, fine. This statement also will be executing n number of times. This number could be anything, 5, 50, whatever it is. And then after that, the value of j will be increased. So I'll say, okay, fine. The value of j also will be increased n number of time here. Okay. Then once this is done, then after that it will generate a new line. Okay, fine. Then the new line also will be generated. So let's see, for time being, I'm just ignoring generation of the new line. Okay. Then again, I will be increased. So I will be increased once again. So I'll writing the I part over here because this first bracket is for the I. This for the outer loop, and this is for the inner loop. So here I can see that, okay, yeah, I will be increased once again n number of times. So I'm saying, okay, fine, it will be increased n number of times over here. Okay. And then if you really want to include this line also, because this line is part of the outer loop, it's not written inside the inner loop. So I'll say, okay, this new line also will be generated n number of times over here.
Hey, what's up everybody? In this video, you'll learn how to visualize exponential time complexity by examining recursive Fibonacci. So we'll start by examining this recursive implementation of Fibonacci. So let's imagine that we pass the number 4 to our fib function. So at this point, 4 is our value.
No. It's not 2. I'm talking about n squared. N squared. N squared. Asymptotic notation. Bro. Wow. What to analyze and why to analyze methods. Take our notation and compare how to check our rhythm exercises and practice. What to analyze. Analyze the resources used. Space time. Why? Why analyze? Front I could algorithm. It takes time to write code and front end. How fast? The space complexity of an algorithm is a memory space. Then the space complexity of an algorithm is a memory space that an algorithm or a problem takes space. Memory space. The space complexity of an algorithm is the total space taken by the algorithm perspective into space complexity includes both auxiliary space and space used by input. Now we don't know what auxiliary space is, so we go to GPT and we ask, what is auxiliary space? Auxiliary space refers to an extra space within the space used by analytics. And the additional memory that an algorithm has to perform its operation. In contrast, the space is a bit which is inherent in algorithm. Auxiliary space inputs with the space used. Auxiliary space. Okay. So auxiliary space. Okay, back to paint. So let's say, so let's say this is your memory space, and yes, and now we have code and data, and in order to run that we have our memory space or RAM or memory space, but then To do this, we need some extra variables. So we have auxiliary space. Okay, auxiliary space. So that could be stacks, temporary variables, and moves everything. Stacks, temporary variable, stack space, data structures, and data structures. All right. So what was it again? Auxiliary space refers to the extra space used by an algorithm. Auxiliary space. Extra space used. Input space is the number required to store the data provided space. This space is necessary for an algorithm. Auxiliary space is extra space. Auxiliary space is the extra space or temporary space used for an algorithm. Check the whole program in 5 minutes. Guess which one takes longer time and why. Okay. This one takes longer. Okay. So I'm going to say this fragment of code or this block of code is. So this is going to be O N. So O N squared. So is this block of code big O of and this is the power 2. Yes, the given block of work and steps. Outer loop the function and the change iterates n times. For each iteration of the outer loop, the inner loop, which also means it iterates n times of iteration, the n times of. Okay. So everything was settled. Okay, so now if there were 3 nested loops, would that mean the code is big O of n cube? Yes, if there are 3 nested loops and each iterates n times, it's okay. But what if the loops were not iterated n times, rather fixed number of loops this mean? In which the input. Okay. All right. And obviously this would mean this would, and this I think is correct me if I'm wrong, but this code is big O. First look. No. Time complexity. Running time of an algorithm is related to the size of the problem. All right. Speed of the computer, architecture, compiler reviews, optimizer not. Okay. Now running time for the algorithm depends on running time of the algorithm depends on. That's a nice ass card. That's a nice ass card. Supra. Kinda ugly though. Running time of an algorithm depends on the size of the input hardware, compiler, hardware, speed, computer. Is it speed hardware? Is it the speed of the computer and no, dependent on the architecture of the computer? Yes, you're correct. Okay. Speed of the computer, architecture, input size, and the compiler. Algorithm analysis. Find out the relation between the size n and random time. Describe how Tn works and implies based on asymptotic comparison with the relations. Now, I have no idea what this means. Which only means that we go to YouTube and then look it up. Yo, chill. Copy this. Copy. No control. Yes, asymptotic analysis. Yes. A deeper understanding. Yeah, alright, we're gonna watch this one. But before that, Microsoft app for making notes in textbook PDFs and highlighting. Microsoft OneNote digital note taking app. PDF reader by Zoro does what you want. I think it highlight my heart. See annotations. Any text viewer. Yeah. Microsoft OneNote is Microsoft OneNote free. Okay. All right. So that means we're going to download it. Microsoft One. Damn, I have it, man. Oh, no, I don't have it. Shit. No, damn, please. Oh, damn, I have it. Yeah. Oh my god, I forgot my email. Okay, wait. Outlook. So I'm gonna send myself an email from my university account. Gonna. Yes, man. Bro. Yes, can you see that? But yeah, nope. Yo, chill, bro. Damn. When you are ready to organize, next, give yourself some room to focus.
Bogash. Hi. What distinction, Bogash?
ఏమి
Orientation.
పని చూసుకో
Bogash. మర్చిపోతున్నావు వినాడు కొంచెం అలా లేదు కానీ నువ్వు అన్నాను తప్పలేదు యూనిఫామ్ని వచ్చిన బొంగాష్
ఏం కావాలరా రే
కంపెనీకి వచ్చిన బొంగాష్ నాకేం వద్దుకుపోయినా నేను నేర్చుకోను
select file
ఇది ఒక బొంగాష్ పాలు దొరికేది కాష్ ఇది ఎత్తుకోబోతావు చాలు బొంగాష్ హాయ్
In this video, I'll be showing you how you can turn on dark mode on OneNote. So I have mine OneNote in Danish, but I'm going to explain everything in English. So first of all, what you need to have open is your OneNote program. Then you need to go up to the OneNote here and click Settings.
Läs din elektriker, Bo Jensen.
Varmt välkommen till våra fina skolor på Jensen Komvux.
So let's first look at things just on the Windows side. If you go to the settings in Windows, so I'm starting on a Windows 10 PC here, and then you go to personalization, you can see that Windows right now is using the dark mode. So go to personalization, go to colors, and then at the bottom of the colors personalization settings, there is a default app mode, light personalization, go to color here. And then you go to personalization. You can see that Windows right now is using the dark mode. So go to personalization, go to colors, and then at the bottom of the colors personalization settings, there is a default app mode, light or dark. So once you enable dark, then obviously you've set Windows 10 for the default apps to use dark mode. So now as I go back to an Office application.
Yes, all right. Does that, bro? Okay, yes.
Hej Sverige! Hur mår du? Många beställer sina recept på nätet. Gör det du också på apoteket.se och hämta dem tryggt och bekvämt på ditt apotek. Välkommen till hela Sveriges apoteket.se.
I love to work in a multicultural environment, but that's the beauty of being here, that you are.
Okay, so what we're going to discuss today is asymptotic bounding. It's very important for algorithms, and this is generally something that if you don't have a sound fundamental understanding of, you're going to be mistaken in an interview. You're going to say a complexity that's completely wrong. Again, if you have not subscribed to the channel, subscribe to the channel, like this video. So when we see a single for loop, doesn't that mean linear time? When we see two for loops, doesn't that mean quadratic time, right? Not always. So I think what we have to look at first is a little math and a little calculus. I was never amazing at calculus, but to really understand asymptotic behavior, we need to look at what asymptotic really means. So what does asymptotic behavior really mean? So I have a graph here. So what is this graph? So maybe I don't know the.
First of all, what is asymptote? Come on. What is asymptote? In mathematics, between one to one, a function approaches but never quite reaches. What does that mean? Approaches. Asymptotes can occur before. What are straight line that literally approaches given field to know a finite destination. Notice what approaches this. Okay. Okay.
Equation for this graph, but I can tell about where this graph is going. So if I took the limit as x approaches infinity, if I go towards infinity, where does the y value go? And you see that the y value goes towards 0. So this is what this looks like. Okay, so now we see the asymptotic behavior of the graph of 1 over x, which is what this graph is. This is the graph of 1 over x. The asymptotic behavior of it is that as x approaches infinity, we get closer and closer to 0. And do you notice our points of interest? What we're interested in here is tail behavior. The idea of asymptotics and looking at an asymptotic behavior is we want to see how does the graph behave getting into very, very large x values, into very large values. This is the idea of asymptotic complexity. Okay, so now we know what asymptotic means. It means tail behavior. But wait, why don't I just measure the elapsed real time? Why don't I just take the wall time? Why don't I just do that? Why don't I just do what I see in LeetCode? I mean, I run my code on LeetCode, and it tells me this ran in this many milliseconds. So I guess I know how strong my algorithm is, right? So that is not the best way to approach things. So in computer science, often problems are applied at a grand scale. Like if you're writing an algorithm for a company like Facebook or a large company, it's going to be used across millions and millions.
Sorry.
How hard is it to make?
Huh?
There's a hook and there's a hook. So you hook the hook.
To the hook.
How long is she been studying?
See, they will see. You don't know. నేను ఆ బెడ్రూమ్ పంపిస్తా మా ఊరు మా ఫ్రెండ్ వాళ్ళ ఫ్రెండ్
ఎవరు
శ్వేత వాళ్ళ ఫ్రెండ్ వాళ్ళు వచ్చారు కదా హాయ్ శ్యామ్.
These people.
But there's no way in heaven in this room to be able to. As long as God is no, ma.
ఎప్పుడు వస్తానమ్మా? మీ ఫ్రెండ్స్ క్లాస్మేట్ కూర్చొని 2 గంటలు చదువుదామంటే 158 నేను లైబ్రరీకి పోతాబా లైబ్రరీకి పోతాను. ఏదైనా తెలియదా రీ నేను 3 hours ఉంటాను. This is important.
So say